Okay, so here's the answer key to that front side of the bonding basics. So a couple things I wanted you to note. If we look at carbon, carbon can gain or lose 4 electrons. Okay, so let's look at that Bohr's model. So we have carbon. Carbon has 6 electrons. So that first energy shell can hold 2. That second energy shell can hold 8. But we only have 4 electrons left. 1, 2, 3, 4. So carbon can either get 4 electrons, if we're doing ionic bonding, can get 4 electrons from somewhere else and fill that shell. Okay, so now it would be full. Or, we'll draw this again, draw our Bohr's diagram. It can lose all 4 of its electrons. Okay, so it's going to take just as much energy to give it 4 extra electrons as to lose electrons. And so that's why carbon can go either way. It can gain or lose electrons. Hydrogen is another special case. So hydrogen, if we draw that Bohr's diagram, it has 1 electron on its first energy shell. This energy shell can hold 2. So it's going to take just as much energy to give it an electron as it would to take that electron away. So hydrogen can gain an electron or it can lose an electron. And so we write that it can gain or lose one, or it has a positive or a negative oxidation. Okay, here's the answers to the bottom ones. Okay, so if you didn't get all these answers, pause the video and check over your answers. Okay, so this is your ionic bonds. Ionic bonds are when we gain or lose electrons. And so your answers, atoms will transfer 1 or more electrons to another to form a bond. Each atom is left with a complete outer shell. This type of bond forms between a metal and a non-metal. So make sure that you know and understand that. I may ask you on the test, is this an ionic bond or a covalent bond? And you would have to know those 2 atoms that are being bonded and whether they're metals or non-metals or if they're covalent bonds. So we did examples 1 and 2 in class yesterday. So we're going to do potassium and iodide. So the first thing we want to do is we need to look for our oxidation numbers for potassium and for iodide. So we have potassium here. Our oxidation number is +1. So we're going to put a +1 right up here. Iodine is right here. It has an oxidation of -1. Okay, so the +1 and the -1 equals 0. So now we know we're good to go. We're going to have 1 of each of them. So then we draw our Lewis dot diagram. Potassium's in our first row, so it has 1 valence electron. Iodine is in our group 17, so it has 7 valence electrons. So we're going to draw our chemical symbol with our 7 valence electrons around it. Okay, so in an ionic bond, 1 atom is going to give its electron to the other. So potassium is going to give this electron to iodine, and it'll take on a positive charge. Okay, we're going to add that to our iodine. Our iodine gains an electron, so it's gaining a negative charge, so it's going to have a negative charge. So when we add these 2 together, it's going to yield potassium iodide. Together they have no charge, but the individual ions do. We're going to do example B4, sodium and oxygen. So let's look at our charges. Sodium has a +1 oxidation, and oxygen has a -2. Okay? We need these to equal each other. So in order to do that, we're going to have to add an extra sodium. So we're going to need 2 sodiums, and we're going to need 1 oxygen. So if I have another sodium over here, we have +1 +1 -2, that's going to equal 0. So we know that we can do that. Okay, so sodium the Lewis dot diagram, it has one valence electron. Oxygen, if we look, it's in group 16, so it has 6 valence electrons. Okay, so it's an ionic bond, so one is going to give the electron to the other. So this sodium gives oxygen its electron, and this sodium gives its oxygen its electron. So now oxygen is going to have 8 electrons around it. Okay, so it's going to have a -2 charge, and our sodiums, we have one sodium, it has a positive charge because it got rid of one electron. We have our other sodium, it has a positive charge because it got rid of the electron, and our oxygen has a negative charge. That's going to yield sodium oxide. Okay, so we draw our sodium, we have 2 of them, so we put our 2 below, and then we have our 1 oxygen. So this would be our chemical formula. Okay, so calcium and chlorine. Step 1, we're going to look at those oxidation numbers. So calcium has an oxidation of 2. So +2. Chlorine is right here. It has an oxidation of -1. So we have +2, -1. We still have a -1 charge, or a +1 charge. We want it to equal 0. So we're going to have to add an extra chlorine. And that has a -1. So our +2 -1 -1 is going to equal 0. So we know we need 1 calcium and 2 chlorines. So I'm going to put the calcium in the middle so I can put my chlorines around it. So I put my calcium here. Actually, that's covalent bond. So you're going to draw your Lewis dot structures. Calcium has 2 valence electrons. Chlorine has 7. So we got to put our valence electrons, 6 and 7, 2, 4, 6, and 7. So calcium's going to give 1 electron to this chlorine, and is going to give 1 electron to this chlorine. Okay, so now it's lost 2 electrons. So it's lost 2 negative charges, so it's going to have a +2 charge. We're going to add that to our chlorine. So this chlorine gained 1 electron. So it's going to be chlorine with 1- charge. This chlorine gained an electron, so we're going to add another chlorine with a negative charge. And so that's going to yield calcium chloride. We have 2 of these, so we have to write our little 2 at the bottom. Okay, and then finally we have aluminum and chlorine. Aluminum is right here, it has a +3. Chlorine is right here, it has a -1. We need to get this to 0, so we're at a +2, so we need an extra chlorine. That's a -1, so we're still at a +1, so we have to do another chlorine. Okay, so we have aluminum. We're going to draw the Lewis dot diagram. Aluminum, and it's got 3 valence electrons. And then we have our chlorines. We have 3 of them. They each have 7 valence electrons. So in an ionic bond, it's important to remember, ionic bond, we're giving those electrons away. So aluminum's going to give 1 electron to this chlorine, 1 electron to this chlorine, and 1 electron to this chlorine. And so aluminum's going to have a +3 charge, plus this chlorine had 1 electron, so it's 1 negative. This chlorine gained electron, so it has 1 negative charge. And this chlorine has 1 electron, so it has 1 negative charge. And that yields aluminum, and then we have 3 chlorines.